Hello there. Today I wanted to talk a little bit about autonomous agents. I guess I gotta zoom in a little bit. Autonomous agents and the future of AI developers. So when I say AI developers, I'm talking about autonomous agents as well, just to kind of be clear about that. But I wanted to talk about sort of LLM-based autonomous agents and the future of those autonomous agents which will be doing programming. In the same way that software developers uh, currently handle development, I think it will be handled by LLM based agents, and largely it is already emerging. If we don't have it by the end of the year, I would be very surprised, but I think that we will have some sort of developer that can work entirely autonomously and can be instructed by a manager and work in a code base effectively and potentially even exceed, at least in terms of monetary efficiency, the average developer, but also potentially productivity and other things. The possibilities are kind of endless, especially if you could deploy a giant, large scale number of these developer agents, which could build applications and systems at a scale that is not currently known. I mean, take a company like Google, which has, think over 10,000 software engineers, and replace that with the idea that each software engineer could be an autonomous agent working in a swarm or a network, and you have this possibility of making something like Google. Obviously, it would still cost a lot of money to get something to the scale of Google, but for a fraction of the cost, we're talking a lot less, in my opinion, than $100,000 a year or whatever the average salary at Google is. The starting salary, I think, is $120,000 a year for a software engineer at Google. And obviously, that's just very quick math, but you know, I think that you'll be able to get a lot more productivity out of a AI developer for the same price. And I'm saying this as a software engineer and developer myself. Obviously, it's not the most ideal circumstance at face value to think about your job being replaced. So I say that in with understanding that it is not as simple as it is. Also, like, it's so cool that we'll be able to have this. It comes with a lot of considerations, but the entirety of the future of AI and our planet kind of does as well at the moment. We're entering a very new age. So with that being said, I want to kind of dive into how autonomous agents currently work and how I kind of plan to build a an autonomous agent which can work in a code base at the same productivity as a developer, as a human developer, and be extremely effective as well. And I'm going to try to do that this year. And it's the end of 2023 as well. I'm going to try to get something semi-working by the end of the year and then iterate on that and build something that truly works. So, with that said, I also just one last little thing. I don't have all of this mapped out in my mind. I don't necessarily know where the video will go. I don't necessarily know what exactly I'll talk about. I'm just gonna kind of do a. I'm winging it essentially, and I'm doing that on purpose because I think that this is sort of an ideation session and a brainstorming session, as well as just kind of conveying the thoughts that I've had so far. I've been thinking about this project for about a week now on a fairly deep level. And so, yeah, I think that is what the video will be like. So, autonomous agents and the future of AI developers. This is going to be the first part. And I just want to kind of talk about how I kind of currently imagine AI agents as working. So the way that I like to make my taxonomies is by kind of breaking a taxonomy down or a system into its various parts. So every LLM-based agent has an LLM as part of it. So we'll make a little LLM here. And then another part of an agent is the agency. So an LLM and an agency. And then another part is going to be, I don't want to do that. I want to copy that over. And then another part is going to be the sense of environment. I also want to make these have a little bit smaller text. I'll just make them large so that this other text is a little bit bigger and or smaller in comparison. Agent, and then sense of environment. And then, okay, so the LLM is sort of the brain, and then the agent is, or the agency is sort of the will of the agent. What is it actually made to do? What is it trying to accomplish? What's its goal is another way of thinking about it. What's its will? Essentially just kind of like the direction or the alignment towards a certain thing that an agent has, as well as its ability to execute on that. And then the sense of environment, if you think about humans and you think about like how an agent must operate, it must be able to take an environment and understand the current state of the environment, and then take that current state of the environment to a new state of the environment. Basically, take the current state to the desired state. And the way that I like to model this, and I'll get back to this, the way that I like to model this is sort of desired state equals, I actually have this written up on my whiteboard in the background, equals current state plus, and then in here we have the current state minus, actually, hold on, desired goal minus current state. So what this means is we have our goal, that's part of the agency, and then we have our current state of the application. So that is where the sense of environment comes from. The sense of environment is the current state of the application. In order to produce the desired state, which is sort of what the agency of an agent does, it needs to take the current state of the application based on its sense of environment, and it needs to add the difference between the goal, the sort of desired state, and the current state. So there's this, the goal is different than the actual desired state because the goal is a concept. You have this goal, it is a conceptual idea of what the desired state actually is, and the difference between that conceptual idea and the current state needs to be added to the actual current state in order to produce the desired state. Now, don't try to critique my math here because I'm sure it isn't very good, but the idea still stands. Essentially, with regards to a code base specifically, the current state of the code base is just like what all of the code is. It's the way that the application currently performs. It's the current state of everything in your code base. It's the current state of your product. Whereas the desired state is whatever your, like maybe your product manager asks you for a new feature, and then so that becomes the goal. The goal is the new feature, in this conceptual space, and then the current state of the application is what your program already does. So then what you need to do is you need to find what is the difference between the goal, which is the application plus the feature in conceptual space, and the current state. And so what you'll find is that the new feature is the thing that needs to be added to the current state in order to produce the desired state, which is probably a super convoluted way of actually explaining this, but it kind of goes to show why the sense of environment is so important. So I'll leave this over here because I do think it's important, and then we'll come back over here to the sense of environment. So the sense of environment is just the agent's way of determining its current state, the current state. of the environment. And then you kind of combine all of these things together in what I've just kind of been calling like a thought loop. So essentially, if you think of consciousness in the human mind as a stream, this is kind of a mimicry of that stream. It's like just a loop where you're continuously taking the previous output as input and building on top of that in order to go from one place to another, from one state to another. And so essentially what you have is, and I bet there has to be a way to connect these in a better way. Hold on. Aha, here we go. Okay. So yeah, agency and sense of environment and the LLM, and I'll explain why I did it like this in a second, are all going to be added into the thought loop. They are all part of the state of the agent's thought loop, which will be a constant iteration, which it'll essentially build over time. So what does the thought loop actually do, though? That's kind of the question. So in a way, the thought loop basically takes the current sense of the environment combined with the agency, and it turns that into a prompt for the LLM. So, for example, if you have a code base, you give the code base in some form, the current state of the code base or the current state of the product, in some form to the LLM, and you say, this is what needs to be changed about it. This is what you are to do with this current state of things. So you take the sense of environment and the agency, and you combine those into a prompt, and then you inject that into the thought loop with the LLM. So maybe a better way of modeling this specific aspect of things would be to add a sort of intermediary step where there is an actual prompt for the LLM. I had a bit of a diagram of this prepared before, but I feel like it needs to be a little bit more. I think it needs to be a little bit better thought out and better represented. Why is that doing that? Come on. Well, that's being a little weird, but you know what? That works. So this gets injected into a prompt, and then the prompt is what the thought loop uses to inject into an LLM. So the thought loop is sort of where this stream of consciousness, of conscious thought, and obviously I'm using the term consciousness really loosely here, but this is where reasoning happens. This is where senses are merged into a way that can actually be processed and reasoned about by the mechanism, and then it can be transformed into some sort of... This is basically where thinking happens, and in a loose sense. But so this prompt is given to the thought loop. So I will draw a little arrow from the prompt to the thought loop, which is basically saying that the prompt is generated and then given to the thought loop. The thought loop sends that prompt then to the LLM. So I'll make a little arrow here because the thought loop is going to send that thought to the LLM, and then the LLM is going to generate a response. Now, obviously, the nature of what this prompt actually is, and then how the thought loop sends that prompt to... I should probably specify this as well. Sends prompt to the LLM is subject to the nature of the project itself. Depending on what the agent does, this may look very different. Perhaps the agent just looks up information. Perhaps the agent just kind of is a Q&A bot. Like, it would be a little weird if that were the case, because that's not necessarily... That kind of says that it should be a different mechanism. Usually an agent is going to try to execute functions. However, it is possible that that is the case, and the functions that the agent might execute are queries and such. So, it's not necessarily cut and dry how this all works. So this sends prompt, and then the LLM sends a response. These could probably be a little bit bigger. Make them a medium size. And then with that response, the thought loop then, based on the decision that was made by the LLM, the thought loop carries on to the next iteration or executes the next part of the step. So what I would say is, like, the thought loop has the chance to do an action performance. And this is kind of where agency is transformed into some sort of influence on the current environment, which will then modify the sense of environment. So basically what that means is that the thought loop optionally can access this action performance component. So optional, it's worth remembering that this is optional. Essentially, what could happen here, and I'll use a little bit of an example, is you have the code base as your sense of environment. You have the current state of the code base, however it's represented, and then you have your agency. Here's the new feature that you need to add, or just refactor the code base generally, whatever it may be. That gets transformed into a prompt, which is given to the thought loop, or even generated within the thought loop. Don't take this as a strict architecture as much as just kind of a taxonomy for describing the nature of an LLM in some abstract way. So, or an LLM agent, I should say. So the agency and the sense of environment are combined into a prompt. The prompt is given to the thought loop. The thought loop sends the prompt up to the LLM. And then the LLM sends a response, which the thought loop can then use to determine what it does next. So this is sort of the reasoning engine, as has been described by Microsoft and such. Optionally, this could mean, I need more information. It could mean a lot of different things, but one thing is the action performance. Basically, and this is optional, but at the same, because, like, it could be the case that you don't want to continue on to the next state of the thought loop. And I haven't necessarily figured out what it means for this to be optional yet. Assumedly, there should always be some sort of next action for the agent. There's always, like, the next best thing that you should do. So perhaps the action performance isn't optional. We'll leave this in red to highlight that. But the idea that I have is that the action performance is what actually modifies the sense of environment. I shouldn't have done that. So when the action performance is accessed, some sort of operation is performed, this modifies the sense of environment. And I actually want to move this over here. And the reason why this is so cool is because that is what changes the nature of the loop. Now, the sense of environment is changed. And when the loop repeats itself, I should make this a different color as well because it is like a loop. When the loop repeats itself, then the sense of environment will have changed based on the action performance. So then the agency plus the sense of environment will change the nature of the prompt, which will then be sent to the LLM, and so on and so forth. Now, it's also worth mentioning that there is a concept of memory, which is extremely important here. You can't just have, here's what needs to happen, and here's what the current state of things is. This equation works one shot, but it doesn't really work on a continuous loop. You need this idea of memory over time. And I think that I have this. I can't really explain why off the top of my head, but I have an idea that an agent's ability to adapt to a code base or adapt to whatever problem that it's trying to solve over time and gain experience in it in some anthropomorphic way is going to be extremely vital to getting the kind of agents that we actually want. As a developer, when you work in a code base, over time you learn things about that code base that become important and inform future development and software engineering decisions. You have a lot of things that you learn just by working in the code base, and because of that, you become a better developer at that specific code base. Any company would prefer a developer that is already familiar with their tools and is already familiar with their code base and works well in it because of that, to a developer who is not, even if they might have some more interesting qualifications. So the ability to, I mean, especially even on a business level as well, the ability to adapt to a specific code base and retain information about that is extremely important. And I think that, I think that that's extremely important. There is a memory aspect to this entire loop, and I'm not entirely sure where to put it in. Like, does it come in on the prompt level? Does it come in on the sense of environment level? Is memory a part of the sense of the environment? In a way, humans' memory is certainly influenced. Our perception, okay, so sense of environment could also be understood as perception itself. Our perception is certainly influenced by our memory. That's why when you look at a tree, you know what a tree is, and you don't really think much about it because you've already thought about it. You already know what a tree is. In fact, you might have an idea that is so primal as to what a tree is that you don't even have to learn about it in your life. However, memory does still exist separately to your sense of environment, to your perception. So, you know, maybe sense of environment is better understood as just the raw data of the senses. Just sort of like when you hear something, like that is a sense of the environment. Or when you see something, that is a sense of the environment. So maybe sense of environment is separate, agency is separate, and there is also a memory aspect to all of this, which informs also the prompt. This goes from the prompt to this also goes to the prompt, and maybe the prompt is where perception actually happens. Maybe the prompt should be understood as sort of the arbiter of perception, which is this sort of condensation. Maybe condensation isn't the right word, but this sort of amalgamation of memory, agency, and senses of your environment. So perhaps that is what perception actually is, because in a lot of ways perception is augmented, and this is sort of where that augmentation is actually happening. I think that in a lot of ways, like, this sort of taxonomy is what an agent actually is it is you take a bunch of sources and you put them into a prompt. The prompt is what the actual agent's perception is. It's what is actually processed and reasoned about, and where decisions can be made and problems can be solved based on. It is the input to the entire thing. That's what perception might be, is input. If you think of the human mind as a function, perhaps perception is input. So prompt, perception. And I might want to actually put some note about that here somewhere, but, let me just, prompt equals perception, just because I kind of want to remember that for later. But essentially, so the prompt is perception, that gets put into the thought loop, and that means that perception is also continuous. It's also a continuous stream in a way. So I'm going to get rid of action performance and replace it with state augmentation. And then this will modify the sense of environment and stuff like that. Okay, so basically, because the prompt is getting sources such as the environment itself, which in a way is a sort of memory, because, well, actually, I wouldn't consider it a memory. Maybe the state isn't memory, but it may have memory in it. And then the memory is also being fed into the prompt and the agency. And because of that, you can make decisions based on all those things. Now, the thing about memory is that it needs to be updated over time. There's some aspect of memory which needs to be built up. You have to, and there's also an aspect of it which is, you have to prioritize certain things. You don't remember everything. There are certain things which your brain certainly decides it should remember more, and there are also different ways of memorizing things. There's procedural memory, and there are other kinds, and I don't have all of the words off of the top of my head. Unfortunately, I need to brush up on some terminology there, but essentially there's memory which is actions, things like muscle memory, like riding a bike, and then there's memory like data, which is your idea of like a concept or something like that. And there are other kinds as well, from what I understand, but because of that, there's this sort of discriminatory nature to memory, which needs to be implemented somehow. How exactly that should be implemented, I can't say that I'm exactly sure, but it is something that I want to kind of think about a bit. Memory needs to be updated at some point, though, and so because of that, I'm actually going to put an arrow between the thought loop and memory, and okay, hold on. I'm actually going to have a separate component here, which will be the memory update mechanism. And whatever this memory update mechanism is, I'm not entirely sure what it is yet. However, whatever this is going to be what updates the memory at every stage of the thought loop. And it's also worth mentioning that this memory being fed in here has a specific nature to it as well. Like, memory isn't just a thing which exists. We don't just want some giant list of all of the things which we know. There needs to be some selective aspect of this. So, like I said, this isn't like a specific architecture, and so I don't want to treat it as that, but if we are going to talk about specifics, a memory would probably be something like vector databases, and it certainly is if we're talking about the current state of things, where memory is certainly usually, in practice, a vector database or a vector store of some kind, which can pull up a data over time. So it's worth mentioning that this is a critical aspect of that actually learning over time thing that I was talking about. That this will definitely make it a lot more valuable, I think. As an individual agent would be a lot more valuable if it was able to learn over time. Just kind of cleaning this up a little bit. IntelliDraw doesn't really have a lot of snap to thing features, does it? That's fine. I will probably redo this in something that's a little bit prettier, but this works for now. So the thought loop is the functional thing. The blue just means that this repeats. This entire process repeats, and it converges on this one spot where all of the magic happens. This is the whole convergence. The LLM is the reasoning engine. The state augmentation is... So, okay, if we were to do this as like a human, obviously an anthropomorphic example, and it simplifies things, and it's not the actual way that things work. But if we were to take a human as an example, the human has some sort of agency. whatever that may be. It could be a goal, like just a one kind of little goal that a human wants to perform. It could be an overarching moral code which they live by, which when they notice things makes them want to act in certain ways. Whatever it is, this is our sense to act in a certain way. It's our sense to act in a certain direction, you might say. So we have our agency, we have our memory, which is, the things that you've learned, the things which you know how to do, also just like your experience over time is kind of what your memory is. It's a lot of different things, practice. And then you have your sense of environment, and that is quite literally your senses. You have, and it's your senses, and it's also your memory. But your sense of environment is just kind of your senses of your environment for this specific case. It's your eyes, it's your ears, it's your ability to read language or hear language. It's your ability to see something happening and feel like, well, okay, I shouldn't say that it's your ability to feel that you need to do something about it, because that's where agency comes in. But it is just the raw data that is being brought into your stream of consciousness, so to speak. Memory is the process by which, I already talked about memory, didn't I? Perhaps my memory isn't very good. But memory is, what I'm trying to say is that all of these things, all of these sort of raw things, which I should probably make into some sort of color, they converge in the prompt. Now, the prompt for us, perhaps that isn't the right way to say it as a prompt, as much as it's sort of like the input. The prompt, though, I think is a good way to say it, because the prompt is, if we were to think of a human as a machine, this is kind of the input to the machine of consciousness, of a stream of consciousness. But this is for the LLM agent. This is the agent's sense of perception. So the prompt is given to the thought loop. Other things might happen in this thought loop as well, by the way. Like, this thought loop could be a lot more complex. That's why it's blue, because it's fancy. And all of these can be complex as well. Basically, they're just all special. I don't know if the colors actually mean anything, but they kind of feel like they do. So the thought loop sends that request, sends the prompt as a request to the LLM, and then receives a response from the LLM. Now, that is when things start to happen. I took away the optional from here, but this could mean updating the memory. There should be some discerning quality to this memory update. This could also mean augmenting the state of the environment. So it's like, when I am going through my life and I'm experiencing reality, when I'm working on a code base, and I'm constantly getting a sense of my environment. My manager gives me something that I need to do. I remember things about my environment, and that all informs my perception. So then, in an iterative process, which it usually is, I take that perception and I decide, one, as I am traversing things, as I am learning about my environment, I am updating my memory. My memory is sort of updating over time, and that will continue to inform my perception. On top of that, state is augmenting over time because I am influencing things. When I'm writing code, I'm changing the files. Technically, you're changing the physical structure of the universe. Energy is transforming from one state to another on a very abstract level. However, in the most tangible sense, you're just making some sort of changes. So I think that this is kind of the best way to understand what a LLM actually, an LLM agent actually is. And now I kind of want to talk about each individual one of these aspects because okay, so every single one of these has a lot of complexity to it and to how it can be implemented. So I want to talk about some like sort of specific implementation details at this point. So memory, let me move this out of the way. So with regards to memory, and specifically with regards to memory in the context of a code developer, of a software developer, memory could be understanding of programming concepts. Memory could be understanding like muscle memory, like how do I type and how do I just kind of go through a specific process. For example, for me, I make a lot of Express APIs. Because I make a lot of Express APIs, I have it pretty much down to muscle memory how to make an Express API. So it's not as much, there is a specific like implementation of memory. I'm going to take this and I am going to paste it over here. I'm going to make it wider, and then I'm going to outline what the different types of memory might be in a different color. So memory could be narrow, I think, like okay, well there's also like the type of memory which is short term. We have this idea of short term and long term memory. So short term, and then we have long term. So from short term and long term, we have sort of a couple of different ways of thinking about this. So when we are completing a specific task, such as in a code base developing a new feature, that often lives in large part in short-term memory. So in short-term memory, there is this idea of these should probably be different colors as well. And also, I don't like the color that these things all are. I'm going to make these all blue and basically say that blue means that these are some kind of complex mechanism. So honestly, all of these should probably be blue. This is derived, however. Because this is derived, I'm going to leave it the same way. But all of these could be considered complex mechanisms. This is also not something that I have to implement. So I'm going to talk about these different kinds of implementation. However, I'm not going to consider these two implementation things that need to be implemented necessarily. Although I guess they all can. You know what? I'm just going to get rid of the color everywhere but the thought loop because I think it's a little confusing. And I'm going to change it to orange. So, short term. Short-term memory is what is my current task? That's one thing. And I'll just kind of make some examples here because and then maybe we can derive some generalizations out of that. So short-term might be like the sense of what am I supposed to be doing? To be fair, that can also be described as agency. So, like, that could also be an aspect of agency, I should say. So, like, what in current task, context, important to current task. That might be a good way to describe it. This is stuff that I should be remembering right now. When I'm learning about when somebody said, okay, so say my boss tells me, hey, you should put a text editor here. I'm going to look up how to put a text editor there, and I'm going to learn a bunch of really specific information. For example, I like to use Mantine as my primary component library. It has a lot of awesome stuff, and it has a rich text editor in it. So, I mean, I have that in my long-term memory now. But for example, if I had just learned about this, I knew that there was Mantine, but I didn't know what I was exactly doing. Well, I'm bringing a bunch of I'm bringing a bunch of memory to my current context, and I'm kind of remembering that. I'm kind of just bringing it to mind. So there's an aspect of memory which is context that's important to the current task, which I'm going to consider short term because this isn't something that I'm going to necessarily. There are a lot of little details which I'm going to bring to mind, which I don't necessarily need to know for a long time. And then we can also talk about this sort of idea of committing short-term memory to long-term memory and vice versa, because short-term memory can be committed to long-term memory, and then short-term memory and then long-term memory can be retrieved for use in short-term memory. So let's do this. Let's change the color of these two things to blue and change this to orange to match over there. And let's say short-term memory can be committed and long-term memory can be retrieved. So another way of thinking of this, I think, is sort of like working memory versus archival memory. So like, I don't need this right now. I'm going to shove, but it does seem important for the future. So I'm going to shove it into long-term memory. And if I ever need to remember it, well, it'll take a little bit longer, but I can get it to short-term memory, and then it will be in part of my working memory. So it's like kind of long-term. I'm going to call this archival memory because that makes more sense in the context of machines, I think. So short-term and working memory. So context important to the current task can be in working memory, whereas perhaps general guiding principles such as like, how do I generally build good software which scales over time or something like that. Like what is a good way to build software? That kind of thing is going to be archival, because even though it is important, it isn't relevant a lot of the times to the current task. It might be relevant in some informative sense and may be brought into working memory, but it doesn't live there. Whereas context important to the current task, obviously that's not a specific example of memory, but it does live in working memory. So I said this was a brainstorming session, so I'm probably going to change up a lot how this all kind of should be understood. But I guess the best way to understand all of this, I'm going to actually swap these around because I think that kind of makes a little bit more sense. And man, I love that I can just rotate that all around and it just works. Excalidraw, by the way. Excalidraw. Amazing little application. Very nice to use. Super simple. It doesn't even have like the whole snap to grid features, and I think that's because if you have snap to grid, then you focus on that instead of just focusing on getting stuff on a whiteboard. So, okay. You have your archival memory, and then basically there is this sense of bringing your archival memory to the working memory. And I'm actually going to keep this here, but because this archival memory can be retrieved and brought to the working memory, I think that that's important. But there's also the sense in working memory of sort of the opposite happening, where I have learned something new and relevant to future tasks. So if I learn something new, I'm not going to add that second part yet, but if I learn something new, then that is going to be in my working memory initially. If I go over to Rich Text Editor and I'm looking through it and I'm like, oh, you know what? Rich Text Editor uses TipTap. Oh, that's awesome. Okay, I didn't know that. Now that's in my working memory, and then there is a discretionary mechanism which would say my working memory is going to be put into my working memory is going to be put into my archival memory. So what I want to highlight here as well is that what's actually being used in the prompt is the working memory. So the working memory, when it is derived, it is being used, that is what memory actually means in this context. So basically, there's an archival memory store somewhere, probably a vector database or something like that. That is going to be accessed, and from that, we are going to glean working memory. Now, working memory is also a mechanism which can be written to. This is just sort of the current context. So the current context can be retrieved from archival memory, or it can be retrieved from the environment as you learn things. So maybe let's add that in here. There's some sort of commit slash, there's some sort of a read write to working memory, and then there's also a read write to working memory, and then there's also a commit to archival memory, an optional committing to archival memory. So let's just take all this. I'm going to swap it around again, of course. And then, okay, so working memory is going to work through some memory module. Through the memory module, we can commit to can be written to, and then can be read from. So these are sort of the two mechanisms which I would see working, is that the working memory, I mean, in a way, the working memory is just a key value store. And this is a key value store which is used in order to it can be written and read from, and whatever is in the working memory will be read into the current prompt, and then potentially preserved to the next round, whatever it is, by some sort of mechanism. I'm not sure exactly how that works, but maybe that's how it works. Maybe the LLM decides what should be preserved to memory, and the longer that memory is sort of the longer that memory is present in the longer that memory is present in the loop, the higher of a priority it has, the higher of an importance that it has, and then it will be committed to archival memory if it's above a certain threshold, and then when it's fetched, it will be fetched with that priority in mind and ordered with that priority in mind. So I'm just going to kind of make an explanation of all of that because I think that might be important to do. So memory is a read write store. It can be accessed and written to. Every stage in the loop, an LLM decides what to keep and what to keep. The lifetime of a piece of memory corresponds to its importance. Above a certain threshold, memory will be committed to long term. When fetched from long term, it will be ordered by importance. So I think that that's kind of how we should understand memory. Um, so yeah, I'm gonna call it there for a day because I need to call my lovely wife back. But I'm gonna pick this back up and talk more about agency, sense of environment, state augmentation, memory update mechanism, etc. So, all right.